Hello students, welcome to our series of lessons on geography. Today we are going to deal with the topic classification and choice of projections. The objective of today's lesson is to enlighten and help in the process of making a right selection of projections. We shall also endeavour to learn the skills of map making in our subsequent classes. We shall cover our today's lesson under the following heads: meaning and importance of choice of projection, classification of map projections, choice of map projection, choosing map projection based on location, choosing map projection based on distortions, and choosing map projection based on the purpose. Meaning and importance of map projection. The choice of projection refers to the appropriateness of selecting a particular projection for presenting the spatial data of a particular region on the map. The space is related to the Earth's three-dimensional surface, which is converted to a two-dimensional map sheet. The resulting map surface obviously is distorted. These are serious problems in mapping the geographical data. There are a variety of projections evolved under the spur of some specific purpose and difficulty which are confronted with while transferring the various parts of the globe over a plane surface. Therefore, there are different methods in which projections are designed. The objective of these projections are to reduce distortions. Each projection method preserves certain true properties of the Earth while they distort some other properties. Hence, we have to choose the best projection to suit our requirements. While selecting the type of projections, the first thing to consider is the purpose of your map. If your map has a specific purpose, you may need to preserve a certain spatial property. Most commonly, shape or area is required to achieve that purpose. Classification of map projections. There are many different ways of classifying map projections. The desire for a classification of map projections stems from the fact that an infinite number of distinct projections are possible. Hence, the fundamental problem in classifying map projection is the partitioning of these infinite set into a comprehensible and useful number of classes. Several classifications of map projections are to be found in the cartographic literature. The advantages and disadvantages of each, of course, depend on the purpose, just as the properties by which classes are to be distinguished depend on the purpose. Most commonly, classification is conducted based on two factors: classification based on distortion characteristics, classification based on developable surface. Classification based on the distortion characteristics are area distortion, distance distortion, direction distortion, and shape distortion. In order to overcome these distortions, the projections are designed. Some of these projections are preserving area, called equal area or equiareal or equivalent projections. Preserving distance, they are called as also equidistant projections. Preserving direction, they are also called as azimuthal or zenithal projection. Preserving shape of local areas, they are also called as conformal or orthomorphic projections. An equal area projection correctly represents areas of the sphere on the map. If a coin is placed on any area of such a map, it will cover as much of the area of the surface of the sphere as it would if it were placed elsewhere on the map. When this type of projection is used for small scale maps showing larger regions, the distortion of angles and shapes increases as the distance of an area from the projection origin increases. An equidistant map projection is possible only in a limited sense. That is, distances can be shown at the nominal map scale along a line from only one or two points to any other point on the map. The focal points usually are at the map center or some central location. The term is also often used to describe maps on which the scale is shown correctly along all meridians. An azimuthal projection likewise is limited in the sense that it can correctly show directions or angles to all other points on the map only with respect to one or the central point. A conformal map projection is technically defined as a map on which all angles or infinitely small locations are correctly depicted. A conformal projection increasingly distorts areas away from the map's center point or lines of true scale, and it increasingly distorts shapes as the region becomes larger, but distorts the shapes of moderately small areas only slightly. Map projections can be constructed to preserve at least one of these properties. Each projection preserves only one of these properties because many purposes exist for maps. Many projections have been created to suit those purposes. Classification based on developable surfaces. The kind of classifications are cylindrical projection, used mostly on the equatorial regions, conical projections used in the mid latitude regions, and azimuthal projection used mostly in the polar regions. The classification is usually a cross combination of two types of classification, such as the cylindrical may be equidistant, equal area, or conformal. Similarly, conical equal area, equidistant or conformal, and azimuthal equal area, conformal, etc. Choosing the map projections. The process of choosing and selecting map projection aims at finding the lowest distortion, and there is also an aesthetic criteria for the selection of map projections. Personal taste and the projection's influence on the overall map design are additional major selection criteria. Choosing map projections based on location, choosing map projection based on distortions, choosing map projection based on the purpose are the three ways in which the selection of projections can be conducted. Every map must begin either consciously or unconsciously with the choice of a map projection and its parameters. The cartographer's task is to ensure that the right type of projection is used for any particular map. A well chosen map projection takes care that scale distortions remain within certain limits and that map properties match to the purpose of the map. Choosing map projection based on location. Generally, normal cylindrical projections are typically used to map the world in its entirety. Conical projections are often used to map the different continents. The mid-latitude regions are well shown on the conical projections, while the polar azimuthal projections may be used to map the polar areas. Transverse and oblique aspects of many map projections can be used for most parts of the world, though they are usually more difficult to construct. The purpose for selecting the map projection. Once the class and aspect of map projection have been selected, the distortion property of map projection has to be chosen. The most appropriate type of distortion property for a map depends largely on the purpose for which it will be used. Choosing map projection based on distortions. Map projections with a conformal distortion property represents angles and local shapes correctly. But as the region becomes larger, they show considerable area distortions. An example is the Mercator projection. Although Greenland is only 1/8 the size of South America, Greenland appears to be larger than South America in the figure. Maps used for the measurement of angles, for example aeronautical charts, topographical maps often make use of a conformal map projection. The Mercator projection is cylindrical map projection with a conformal property. The area distortions are significant towards the polar regions. An example of Greenland appears to be larger but is only 1/8 the size of South America. The second one is map projection with equal area distortion property. This on the other hand represents areas correctly, but as the region becomes larger, it shows considerable distortions of angles and consequently shapes. Maps which are to be used for measuring areas, for example distribution maps, often make use of an equal area map projection. The cylindrical equal area projection after Lambert is a cylindrical map projection with an equal area property. The shape distortions are significant towards the polar regions. Number 3, the projection with equidistant distortion property is achievable only to a limited degree. That is, true distances can be shown only from 1 or 2 points to any other point on the map or in certain directions. If a map is true to scale along the meridian, that is, no distortion in north-south direction, we say that the map is equidistant along the meridians. For example, the equidistant cylindrical projection in the following figure. If a map is true to scale along all parallels, we say map is equidistant along the parallels, that is, no distortion in east-west direction. Maps which require correct distances measured from the center of the map to any point or maps which require reasonable area and angle distortions often make use of an equidistant map projection. The equidistant cylindrical projection, also called as plate carry projection, is a cylindrical map projection with an equidistant property. The map is equidistant, true to scale along the meridians in north-south direction. Both shape and area are reasonably well preserved with the exception of the polar regions. The general shape of the mapping area should also match with the distortion pattern of a specific projection. If an area is approximately circular, it is possible to create a map that minimizes distortion for that area on the basis of an azimuthal projection. The cylindrical projection is based for a rectangular area and a conical projection for a triangular area. The choice of the map projection class, cylindrical, conical or azimuthal, depends largely on the general shape of the mapping area. In summary, the ideal map projection for any country would either be an azimuthal, cylindrical or conical projection depending on the shape of the area, with a secant projection plane located along the main axis of the country or the area of interest. The selected distortion property depends largely on the purpose of the map. Choosing map projection based on the purpose. The choice of projections depend upon the map purposes. Suitable equal area projections for thematic and distribution maps include those developed by Lambert, whether azimuthal, cylindrical or conical. World maps for weather data Continuous world maps are useful for showing the wind system, ocean currents, isobars, etc. The choice will be restricted to a few because only homolographic or equal area projections will be more suitable for them. Distribution of tropical and subtropical crops like rice, cotton, tobacco and sugarcane etc. is to be shown over the world map. Cylindrical equal area projection will be more suitable than molweeds and sinusoidal, as in this projection within 30 degrees of the equator distortion is much less and the meridians and parallels intersect each other at right angles, so that the shape is relatively much more correct. Moreover, it is also very easy to construct this projection. Mercator's projection is very important in that it is the only projection which correctly represents compass bearings by straight lines from all points. As such, it is singularly chosen for communication and navigation maps. Distribution of temperate crops like wheat is required to be shown on the world maps. Molweeds and sinusoidal will prove better than the cylindrical, in which there is much distortion in the temperate regions. Even of the two, molweeds will be more advantageous as it provides for less distortion than the sinusoidal. For topographic and large scale maps, conformability and equidistance are important properties. The equidistant property possible only in a limited sense. However, it can be proved by using secant projection planes. The universal transverse Mercator's projection is a conformal cylindrical projection using a secant cylinder, so it meets conformality and reasonable equidistance. Other projections currently used for topographic and large scale maps are the transverse Mercator's projection. The countries of Argentina, Colombia, Australia, Ghana, South America, Egypt use it, and the Lambert conformal conic in use for France, Spain, Morocco, Algeria, etc. Also in use are the stereographic for Netherlands and even non-conformal projections such as Cassini or the polyconic. Some map projections have rather special properties. The Mercator projection was originally designed to display accurate compass bearings for sea travel. Any straight line drawn on this projection represents an actual compass bearing. These true direction lines are rhumb lines. Thus, the route of constant direction between two locations is always a straight line. For navigation, this is the easiest route to follow, but not necessarily the shortest route. The rhumb lines are shown as straight lines on the Mercator projection. The shortest distance between 2 points, the great circle path, is shown as a curved line. A gnomonic projection, every straight line on the map is the shortest distance between 2 points. The lines do not have true scale, however. In the 15th, 16th and the 17th centuries, during the time of great transoceanic voyaging, there was a need for conformal navigation charts. Mercator's projections, conformal cylindrical, met a real need and is still in use today when a simple straight course is needed for navigation, because conformal projections show angles correctly. They are suitable for sea, air and meteorological charts. This is useful for displaying the flow of oceanic or atmospheric currents. For smaller countries in mid latitudes like British Isles, Baltic states, France, Spain, etc., there is little difficulty in choosing a projection. Their extent is so small that projection which is easier to construct may be adopted. For the Baltic region and for France, simple conic with two standard parallels may be applied. Simple conic with one standard parallel may be used for maps showing transcontinental railways, for example, Trans-Siberian or Canadian Pacific, etc., which may ideally correspond with the standard parallel along the scale is true. The projection which best fits a given country is always the minimum error projection of the selected class. The use of minimum error projections is, however, exceptional. Their mathematical theory is difficult and the equidistant projections of the same class will provide a very similar map. Dear students, we have learnt today innumerable types of projections available. Therefore, there is a need to classify map projections. The intention is to understand their uses and apply them in suitable circumstances. Several classification methods of map projections are to be found in the cartographic literature. The advantages and disadvantages of each, of course, depend on the purpose for which it is used. Making the best choice is a challenge, but it definitely helps in giving a good visual appreciation of the map.